consumption and also the GDP. Because this is a single equation approach. Actually, this single equation approach means that our dependent variable is a my demand. So when we do the restriction on the lag for this GDP and also the lag for the consumption, the F statistics show that they are significant. Significance means that the GDP actually is significant to the consumption equation. So if there is a significant, so there is a long run relationship between the variables of the first. So there is a long run. So and this is a long run impact. And how about the short run? For this short run, we can get from this error correction model. Okay, so given us this long run equilibrium between the variable x and y, so the error correction models can be written as follows. So we have all the error correction, it means that error correction, the variable in the error correction models appear in the first difference. Right, appear in the first difference. There is a no, as you observe in the long run, no first difference, all in the level from. But in the short run, means the error correction models, the variable appear in the first difference. First difference on the yt, and then on the yt minus I, right? And also the xt minus I. So this is the lag for your x. And this x, you can start from 0, right? It means that you, not x start from 0, sorry. The t, it means that once we read from this equation, the x is start from the changes x in the level, including their lags. It depends on how many lags you impose inside, right? If you impose inside. So let's say you have the k equals to 4, right? Maximum lag equals to 4. So you can imagine here entry is t and then t minus 1, t minus 2, t minus 3, and then until this one, q, right? Sorry, I think I messed up here. This one. So you start from the level t minus 0, and then t minus 1, t minus 2, t minus 3, up to t minus 4. So you have 4 lags for each independent variable. And it depends on how many independent variables here, right? That's why it depends on the number of k, right? So it depends on how many independent variables here. So this is a general expression how we write the variables, the independent variables here. Then for this yt is straightforward, yt minus I. So it starts from I, again it's not start from 0, because it's t minus 1 up to t minus how many lags here. Then how about this lag? What is this? This refers to the ECT, error correction term. This refers to the error correction term. So actually it's our models, right? This one. Where's my long run? Yeah, this one, right? Is y. This one change become minus. Right, minus this component. Right, from the long run is actually the difference between your y and also the y hat. Y and the y hat. So y and your y hat, estimated models. So this is referred to your ECT, and then you minus 1 period here. So it's a lag 1 period. So actually it's referred to residual like in the long run and then minus 1. So this refers to the error correction term. Okay, and this actually refers in the long run relationship, right? In the long run. The data. Actually this one in the data, right? The data is a long run. It's from the long run estimation. So what is the ECT refer to? Actually this ECT refers to the speed of adjustment. How fast the short run deviation to the long run equilibrium is used to measure the speed of adjustment. So how quickly this equilibrium is restored? How quickly the equilibrium is restored? Actually, it's similar like the ECT we discussed in the VCM. Right, this is the equation. The idea remains the same. So how quick the equilibrium is restored? So the faster the speed, the faster the equilibrium being restored in the long run. And this coefficient, right, is between -1 and 0. Between -1 and 0, then maybe some of you will get like it cannot be positive. If positive means that cannot be restored, right? So you have to be negative and you want to be restored negative and significant. So that's only one. So okay, so this one is based on the just now the models. So because this one is from ARDL 40, right? ARDL 40. So because of variable measured in the first difference in the error correction term, so this is the error correction models, means that first difference in the variables. So this is a ECT. This is a ECT, error correction term, negative and significant. Negative and significant. So where is the GDP? Where is the GDP? Do you remember the GDP in the ARDL model is in the level, as suggested by the ARC, right? It's a level. So once your first difference, the level will become disappear, right? Means your first difference means actually no, right? It's 0, right? It's 0 here. So it means that your first difference actually is nothing, right? So it's not okay in your error correction model. So like this. Okay. So what you can expect? ECT actually error correction term is negative 55.46% deviation is corrected within 1 period, right? It's within 1 year. Since the variable are annually, right? It's annual. So it's corrected within 1 period, within 1 year. So it's quite fast, right? 55.46%. So it's a speed of adjustment. So how fast of any disequilibrium between these two variables is corrected within 1 period. So this is how we interpret based on these error correction models. So where to get the error correction models? So this one is based on the SIC. I try this now. If I based on AIC, I click OK. Then I go to just now go to view, right? Go to view, and then you can get your error correction models from here. Error correction result. Error correction result. Then this is my error correction models. These are different. This is the form, and this is the error correction models with the coefficient here similar. So you go to the view. Maybe you have an EU version 12, different presentation, right? But the result same, right? Result same. So you go to the view and then go to the error correction result. Then you will return you the error correction models. With this called in COINTEQ. This is the coefficient. This is the error correction models. And actually, right, in these error correction models, so in the journal articles I show you later, you also report the R-square, also report the diagnostic test as well, right? So how to get a diagnostic test? You can go to the view here, and then diagnostic for the residual. Because just now your friends also got discussed how we going to determine, to justify whether this model is it valid or not valid. Because this is econometric, we have to make sure the model we estimate the residual, especially the residual are well behaved. The well behaved here means that the residual actually fulfill the assumption. The classical linear regression model assumption again, right? Again, why? Because it is based on the OS, orderly square method. So the classical linear regression model assumption include like the model should be no autocorrelation, the model should be no heteroscedasticity, the model should be no misclassification error, the residual follow the normal distribution, right, etc. So many, right? So I can use this histogram to test whether the residual follow the normal distribution or not. I can use the serial correlation to test whether the residual is equal serial correlation or not. I can use a test, use a heteroscedasticity test to test whether the variance of the residual are constant, right? There are so many other tests. Then you say, what's that? Actually, the journal articles I show you later will discuss all the things. So profit test. Then you click OK. Test oscillation times the R squared 0.96 insignificant. So there is a no evaporation as well. Then how about are the variance for my residual constant or constant? Diagnostic for the residual again. Click on the heat transfer scarcity. So there are a lot of tests to test for the heat transfer whether the residual are constant or constant. So including Busch-Buggen-Geoffrey, R, Y. So let's say I click on the Busch-Buggen-Geoffrey. Click OK. Observation times R squared. 0.31 p-value, insignificant. So again, no heat transfer scarcity. Okay. So there is a result for the diagnostic test. What else I need to concern from this area? How about the stability? Okay, Ramsey reset test to test for whether the model is it misspecified or not misspecified. Number of filter default is 1. I can OK see. Oh, F statistic is significant at 10%. But not at 5%, right? Okay, maybe there is maybe you do not have a model misspecification at 5%. As I can calculate that. How about the stability? Stability, go to the recursive estimate. Perhaps I try the Pearson of square to test for the stability. You can OK. Oh, so nice. We see the critical value. The two red color line here refer to the critical value. So the test is within the critical value. So model is stable. My error correction model is stable. Then you say how I can get all this information. If you want to know more, you can read all the journal articles here. So maybe I pick up one. This one. Okay, oh. This one. What is this? Let me see. Oh, this is random causality. Oh, this is just do random causality. Right? Let me see. Yeah, it's a stability. Okay, this was sure. This is not. This just want to show you the random causality test. I want to see the area with this one. This one maybe can. This one published in the using this demand models published in the Applied Economics. Then you can see this VCN representation. Okay, it's a small sign. Okay. This area, these are models. So once all the journal articles they will present their models, these are models, and then you read up how they define the variables, right? Define the variables, and then their where's the sources, right? From this international financial statistics, right? IMF, right? This is how they report up, right? And then here, this one, unit test, right? So using ADF test, parent, MES test, and then they report in a table, right? So for your research project or for your assignment, you just do like me, right? You do like me, feel free, right? You have to summarize the result in the presentation footnote, like this. Summarize the result in the table nicely. Don't do the thing like I do just now, copy paste the figure and picture here, right? That's not nice, right? Not nice. So you can do the thing. Where's my another one? Run very. Do the thing like this. Like this one, right? This not good enough. Copy paste the restriction lah. So different presentation, right? The videos you can go through lah, and then they do the forecasting performance based on four different models. There's no AIL. I want AIL. Yeah, it's saving. Let me see. Okay, again, models. Where's the model? Model is here. This is saving models. Right. So when you go through the journal articles, you can see, oh, this is saving model. The determinant was saving. So you can see how people define the variables. And then econometric method. They got integration, Angel, Granger, right? Bois, VCN. Based on mentioned. Then using root test, using Johansson, Jesserin, and then do the restriction test, test exclusion, normalize the value, error correction models, error correction models here. So different models, error correction model, you see, error correction model, so long. There are four different error correction models. So now you can understand how to read the error correction model, right? Or should calculate the first difference, right? If someone like to see, error correction model in the level, so you say something wrong, right? So now you have understanding. Error correction model should calculate the first difference. Because the short run, right? Then where is the ECT? Here, negative, right? Yeah, now you know where is the ECT, right? Negative. Then how to read the short run? If I want to see the GDP, right, for the short run, then this is the one, right, on the saving for this equation. That's the thing. Random causality based on VCN. So now we can take a look whether the ECT is significant or significant in each equation. So the lecture, I just let you to know how to go through the things, right? But where is my error correction model? I the upper bound here, mean like my case, then you reject no co-integration. Reject the H now. Where's the H now? The H now is no co-integration. I also confused it. H now means no co-integration. So it lies between the two bounds, inconclusive. It cannot make any conclusion. Cannot make any conclusion. It's fall within the bound. Where is within the bound? If let's say unfortunately your test statistic is between these two, lower and upper, between. You cannot make any conclusion. But you found that all the published paper that published already, normally either they found no co-integration or co-integration. Unlikely you will found in between one, right? Maybe empirically you will found that, but all the published one is all either below or above. So then to see the means appropriateness of the ARDL, then use the Bush-Goffey to test for serial correlation, and then also they use the SIC criterion and SIC so to see how they report short run dynamic. So they got short run model as well. So this error correction model is based on short run. So you have to when you read this result, right, have to see what are the variables, what are the value in the parentheses, and what are the value in the bracket. Right, parentheses is the second error, bracket is the second one. Right, and then supplement your result with the diagnostic test. Right, diagnostic test, including the autocorrelation test, Hitchcock scarcity test, Jack-Barron anomaly test, another set of Hitchcock tests. Right. This ASH test and the Hitchcock test actually refer to test for the variance, right? For the residual, are they constant or not? And also got reset 2 times 3 times. And then stability test, right? Just now I show you the diagram, whether the coefficient, whether the test statistic fall within the 2 lines. That's if stable, report stable. Not stable, like this one not stable. And this one stable. If touch the line like this, outside the line, not stable. Right? Touch the critical value, mean outside already, become not stable. So only the stable is like this, within. Touch a little bit, not stable. And you can see the timer, where it touches, somewhere around here. Then somewhere around here, right? This is how they report, right? And then also got Fusion 20 as well. Then you can see actually what they this one for stability as test as well. So you can go through the journal articles now, right? And this exogenous test, so-called exogenous test. They just put a restriction to test whether are they very weak and super exogenous. This something like that. Okay. So there are so many other papers you can go through it. So come back to my lecture now. So ARDL bound test, right? You can apply. You can apply also. Once you go back home, okay, you can apply using the ARDL bound testing, right? So you choose this limit equation, choose the ARDL, then you can see, right? Based on this one, you can form your long run, right? This ARDL 1040. What is a 1040? It means that my ARDL will be lag 1 for my dependent, 0 for my lag 0 for my income, and then lag 4 for my interest rate, and then 0 for my real effective exchange rate. And now you know what selection criteria is used. SIC, right? SIC. How many model actually help me to evaluate 500? Wow. Then you come out that ARDL 1040 will provide us the minimum SIC. That's why this is a suggested proposed model by using the SIC criterion, right? So if you want to test whether interest rate gradually cost the money or not, we can use the wall test to test it. Wow. So now I run this one, right? Then on the money equation, right? If they're equal to 0, so if they're not equal to 0, so if there is a certain impact, right? There's a certain impact on the money. So I estimate equals to 0 or not equals to 0. Actually, is reflected as interest rate no greater cost the money against alternative interest rate greater cost the money. So my result shows that significant at 5%, right? It's less than 0.05. Right, what is this? Right, see, right, is right. Less than 0.05, still at 5%. So we can set interest rate greater cost of money in the short run. So how about the test statistic? So you know how to read, right? Test statistic, right? So significant at 1%. Why? Is it? Because now it's based on 40 observation. Is it 40? I have 42 sample size, right? So I choose the nearest one now, 40, right? So as you see, if I base on the asymptotic one, it's 2.37. If I base on the precise one, smaller one, my critical value will be higher, right? This is simulated critical value. This is based on the Pasaran paper. They already simulated. You can refer to the Pasaran paper, right? Here, this one, Pasaran 2001. So, significant 11 compare here. All above the critical value up above, right? Yes. All above. If I base on 1%, it's greater than 5.544. Are you going to reject? Sure. It's reject. So reject means what? If you reject, it means that there are significance, right? There are correlation in the long run, right? So this is just based on the test statistic, right? But this is talking about the grandeur. Grandeur in the short run. Now, how about long run? If you want to test for the long run, then you look at the long run. Just look at the long run result. Interest rate, not significant. So we can say that interest rate not greater cost in the long run. So what you can do here, maybe I go to the e-views. Go to view, right? Estimate just now, right? Estimate just now. Here, if I want to see whether the GDP greater cost consumption or not in the short run, significant, right? If you want, if this one is an AITL 4.1, you're going to have a true coefficient now. So you can use a wall test, right? But how can I use a wall test? Yes, can also. Here is C5, right? If I want to use the wall test, how does it work? Go to the view, and then go to the coefficient diagnostic, choose the wall test. Go to the view, coefficient diagnostic, choose the wall test. If you want to do the wall test now, you can do it here, right? Wall test, right? Wall test, wall test. Go to view, right? Diagnostic. DIAG. Diagnostic for the coefficient. But before that, you have to take a look the coefficient, right? You go to the view, diagnostic, right? For the coefficient diagnostic. You choose the coefficient diagnostic wall test. It means that you want to restrict a certain coefficient. So you go to the wall test coefficient. Then here, I just invoke one, right? C5 only. So I just put there C5 equals to 0, right? Because I only have one. If I have multiple, then I can include more, right? Equals to 0. Is significant? Yes. Highly significant, right? Highly significant. Because my wall test is significant at 1%, right? It based on T distribution T or F or chi-square for this case, right, we just type this command in the word test. You can try at home. Right? You can try at home. You can try this one. So you can get this result. So you will find that gradual cost of money in the short run. Then how about long run? In the long run, right? You go to view, then you can look at the long run, right? This one. You should look at this one. Significant or significant? Significant, right? Significant. Should take this one. This should take from the long run result. Look at the long run. So not significant. In this case, not significant because this one is not significant. So no long run. Gradual cost from the interest rate to the money in the long run. How about the strong causal? Yeah. Have you gone through the video clip? Some I showed you last week. Somewhere in the. If you want to try for the strong causal, right? So if you just based on the F test, T test, it's just a short causal, right? Like I did just now, lah. Then how about the long causal? The long causal, and also the negative and significant ECT. All have to be significant. That only can say whether you have the strong causal relationship or not. This is the long run, right? This is the long run. This is where we get the long run gradual cost. This is where we get the short run gradual cost. If the question asks you, is there a strong causal? Then how are you going to answer? It's for the strong causal, right? You not only test the short run, not only test the long run, also need to look at the significant and negative ECT term. So, is it this one significant? Highly significant. But in our case, do we have a strong causal? No, because in the long run, there's no long run causal, right? No. So I only have a short run and with a negative and significant ECT, but I do not have a long run gradual causality from my long run result. So I only can say there is no long run causal, no strong causal. So no strong causal relationship. So that is the thing. Okay? Are you still so right? Understand? Are you okay? Need time to digest? No worry. You can digest before you sleep. Yeah, so you can try to replicate the result, right? You can try to replicate the result with another variables. This is just an example here, right? So how about my consumption case? Do I have a strong causal? So here, my long run significant, right? My long run significant GDP on the consumption. Long run significant. How about my ECT? ARDL? No. ARDL diagnostic, error correction result. ECT significant. Oh, okay. How about short run? Just now also shows very significant, right? The short run, still remember? Just now we go to the view representation, right? It's C5, right? Then I go to the wall test, right? View the wall test, C5. Is it equals to 0 or not? Yeah, highly significant. So is there a strong causal from the GDP to the consumption? Yes. In this example, yes. But in the file I share here, no. Because there is no gradual in the long run. That's why in the red color here. Okay, so these are the two different examples for you. You also can try without the exchange rate, right? You can continue our exercise without the exchange rate, like our case just now, to see whether there is a strong causal or not, right? Yeah, to see whether there are strong causal or not. So you go to the estimate, no. Now it's the ARDL, right? I can go to the open as an equation, and then as an ARDL, then I use 4 lag, then I base on the AIC 104. If I want to test whether interest rate rental costs the money or not. So, what are the coefficients? C3 up to C7. So I go to view, then I go to the vortex. C3 up to C7. So I type C3 equals to C4 equals to C5 equals to C6 equals to C7. Are they equal to 0 or not? So, significant? Yeah, significant. So, that's a short run, right? Short run tangent cost from the interest rate to the money. How about long run? Go to the value, go to the cointegration relation, and then my interest rate, 0.62. The p-value not significant, so straight away. No need to look at the ECT, already no strong causal, right? Already no strong causal. So no strong causal from my case with like the example just now with the real effective exchange rate models. Now how about my ECT? Right, my ECT. I want to see my ECT. I go to error correction result. ECT significant. Same conclusion, no? So no long run, but with negative and significant ECT, and with the short run, but no long run. So again, no strong causal answer. Interest rate and also money. Right? Okay. You want to try? I want to go back home already. This time. Are you okay? Still need time to digest your food? Or your ingredient for tonight before you go to bed? So please enjoy the things. So practice practice make it perfect, right? Practice because next week we're going to touch on the panel already. Come on the panel. So